is determine whether a reaction is at equilibrium. And we're going to do that by calculating what we call Q. And Q is essentially the same, it is the same calculation as K. But it's Q because we're questioning whether it's at equilibrium. So as we recall, K allows us to tell whether a reaction is going to occur. We have a large value of K, and then there's going to be product favored. It favors the forward direction as written. If K is less than 1, it favors the reverse direction as written, which means that it's reactant favored. We have seen what I'm stating here in step 2, which is that if we want to predict equilibrium concentrations, we can use ice tables, okay? But if we want to determine whether a reaction is at equilibrium given certain concentrations, we have to use what we call the reaction quotient Q. And then once we have calculated that, we can determine what direction the reaction needs to proceed to the reactants or to the products in order to reach equilibrium. So as I said, calculating Q, reaction quotient, is the same calculation as for K. So using our generic equation here, we have A plus B yields C plus D. Q is still going to be concentration of products raised to their stoichiometric coefficients. Whoa, what did that do? Okay. Over reactants raised to their stoichiometric coefficients. So again, same as K. Well, what I'm going to end up doing is comparing the value of Q to that of the value of K. And if we find that Q is equal to K, that means that the reaction is at equilibrium. Okay, it's not going to go either to the reactants or the products. It is where it will be. If Q is less than K, thinking about this fraction, what that means is that the concentration of products is less than the concentration of reactants. And so the reaction must proceed towards the products in order to reach equilibrium. So we have less products than what we would expect at equilibrium. So we have to form more to get to equilibrium. If Q is greater than K, we have more products than reactants. And so the reaction needs to proceed toward the reactant side in order to reach equilibrium. Everyone okay with that? Okay. So let's look at an example. Look at our formation of ammonia, which we've been looking at it, kind of often. It's a great reaction. What can you do? So we have nitrogen plus 3 hydrogen in equilibrium with ammonia. The K for this reaction is 6 times 10 to the minus 2, so less than 1. So it's reactant favored, right? Normally. That is not that's not the same thing as Q, okay? Those are different things. So at some point, this is what this problem is saying, at some point during the formation of ammonia, we take a sample and we find that we have 1 times 10 to the minus 5 molar nitrogen, 2 times 10 to the minus 3 molar hydrogen, and 1 times 10 to the minus 3 molar ammonia. And so the question is the reaction at equilibrium? So we're going to use these concentrations that were given in Q. They may or may not be equilibrium concentrations. That's what we're trying to figure out. Okay. So to calculate Q, same as what we would do for K. So concentration of ammonia over the concentration of nitrogen times the concentration of hydrogen cubed. And we're going to use these concentrations given to figure out if those are equilibrium concentrations. So in our numerator, we're going to have 1 times 10 to the minus 3. In the denominator, we'll have 1 times 10 to the minus 5 for nitrogen and 2 times 10 to the minus 3 cubed for hydrogen. And we end up with 1.25 times 10 to the 10. So if Q is 1.25 times 10 to the 10, we know that this is much greater than 6 times 10 to the minus 2, which is K. I don't want you thinking of multiplying. Okay. So if we have Q that is much larger than K, which direction is the reaction going to proceed to reach equilibrium? Okay, I like to think about the, we're pointing in directions. I like it. Y'all are going like that, I think? Yeah. Okay, reactant side. Good. So we have more products than expected at equilibrium. Okay. So the reaction, RXN, will proceed toward the reactants. So we're going to need to form more reactants to reach equilibrium. And that's because we know that because we have a very large value of Q, which we've compared to K. Yes?
Is that usually eliminated towards reactants?
That I think that is usually how it's written, is it's going to be proceed toward the reactants or the products. I'm going to make sure there's no left and right on the exam. I hate left and right. Are there other ways that you're thinking of? Because I think there is another way that I'm not thinking of right now. Yeah, it could be written as forward and reverse. So we could say that the reverse reaction is likely to occur. Good call. So NH3 going to N2 and H2. Question? Yes?
You say the more products
So I'm saying it's more products than what we would expect at equilibrium, so more products than reactants. K represents our expected concentration. Yeah. All right. We will